Welcome back. This time we're going to be talking a little bit more about limits, specifically one-sided limits and infinite limits. In the last video we talked a little bit about limits, and I was probably dancing around these two topics. So this time we're going to define exactly what I mean by a one-sided limit and how it relates to a just normal, which is a two-sided limit, and also explain better about how we can denote limits where the function is approaching infinity, which I'm just going to call an infinite limit. Okay, so let me set up an example. Okay, so this example is showing what I mean by a one-sided limit. Notice there are these little pluses and minuses now near the number on the limit, and that is going to denote the minus for a limit as x approaches 0 from the left, or values for x less than 0. Plus means from the right, or numbers bigger than 0. Okay, so minus is always from the left, and plus is always from the right. Think in terms of a real number line. You know, as you go to the right, you're getting more and more positive numbers, and left, smaller numbers. Okay, so in this function, the limit as x is approaching 0 from the left. As x is approaching 0, our function is approaching a height of 1, and therefore this limit is 1. But as you approach 0 from the right, our function is approaching a different value, -2. Notice in this example, because both of these are wholes, if the question was, what is f of 0? F of 0 does not exist. And DNE for does not exist. Okay, so this is the left-handed limit, this is the right-handed limit, and if I were talking about the normal limit, or you might say the two-sided limit, because these two are different values, as I said before, when you're approaching two different values, this limit does not exist. Okay, in other words, to put it formally, now that we sort of know what a left and right-handed limit is, or one-sided limit, that the limit as x is approaching a number from both sides only exists if both of these exists and they're the same value. Okay, normally I just abbreviate it and write it like this. Okay, so if the limit as x approaches a from the left of f of x equals L for some real valued L, and the limit as x approaches a from the right of f of x is also equal to L, then you can say the limit as x approaches a of f of x equals L. And I'm stressing that L has to be a real number, can't be like infinity. Okay, so this is what we mean by the two-handed limit. Only exists if both of these exist and they're equal. Okay, if one of them doesn't exist, or they equal different values, then the limit for both sides doesn't exist. Okay. Okay. Infinite limits. Okay, so let's now do an example of an infinite limit. What I mean by infinite limit, which is going to be for functions that involve vertical asymptotes. All right, so here are two examples of some infinite limits. Limits that involve infinity, the graphs have vertical asymptotes. Let me clean up this graph over here, because this is looking like it's going a little bit too high for it to taper off like that. Okay, that's better. Okay, so for the first graph over here, f of x equals 1 over x has a vertical asymptote x equals 0. But as you approach 0 from the left, you're going towards plus infinity. This is how you write it. As we go from the right, it plunges down to negative infinity. Okay, so you just put a plus symbol in front of infinity. That means you're going up forever. Minus infinity is going down forever. And because these two don't agree, you would just say your limit as x approaches 0 doesn't exist. Okay, now on a graph like this, where from the left and the right you're both going to plus infinity, in that case you can say that your limit as x approaches 0 from both sides is also plus infinity. So when you're dealing with infinities, the left and the right, if they're matching infinities, then you can say that your limit from both sides is that infinity. Like if they're both plus infinity, your limit from both sides is plus infinity. If they're both minus infinity, you would say your limit from both sides is minus infinity. But if the infinities don't match, then you would say that your two-sided limit does not exist. Okay. That's all I really wanted to talk about in this video, a little bit shorter than my other videos, but really is just clarifying some of the things that we were talking about in the last video. Anyway, bye for now. Have a good day.